so hopefully my Mobi board is going to connect. So find the coordinates of circumcenter triangle with vertices. So we're going to do this side first. Negative 7, 4, 5, 8, and 8, 2 by completing each step below. So first of all, why don't you go ahead and we'll just kind of graph those points. So we have our triangle on your paper. So negative 7, 4, 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4. There's point A. Okay, point B is going to be at 5, 8. Five, 8, and then 8, 2. 6, 7, 8, 1, 2. Is that right? Did I draw that? I think I did. And then draw a triangle connecting those points. Everyone did that? And label your points. Okay? So I'm going to label this point A, B, and C. Questions so far? Easy enough? So this is good practice and good review for finding midpoints, slopes, all that kind of stuff. Maybe I should use a darker color or something. Let me see. So how do I find the midpoint of AB? Who can tell me how to find the midpoint of AB? What do I do? The x-coordinates. Yeah, add them together and divide by 2. So the midpoint formula is right there, right? So you add negative 7 plus 5 divided by 2. That's going to give you your x-coordinate, right? So that's, what is that? Negative 2 divided by 2, which is what? What's negative 2 divided by 2? Negative 1. So that's my x-coordinate. And the y-coordinate is 4 plus 8 divided by 2. So 4 plus 8 divided by 2, which is 6. So the midpoint of AB is going to be at negative 1, 1, 2, 3, 4, 5, 6. So look, if you draw your picture right, you could actually plot it on that, right? Okay, so now I have to find the slope of segment AB, which the formula is right there. So you can either go this, call this y1 and this y2. I like to go the other way around, so I'm going to call b y2. So I'm going to go 8 minus 4. Whoops. 8 minus 4 divided by 5 minus 7, right? 5 minus 7, which makes 4 over 12, yes? Which is 1 over 3. I think I did that right. Did I did that right? I got a key that I made before to make sure that I'm doing this right. I did this. I think I did it right. I did it right. Okay. So now you have to find the perpendicular slope, the opposite reciprocal slope, the segment AB. Who can tell me what that is? What's opposite reciprocal of 1/3? Because remember, we're finding the equation of this line that goes like that, right? So what would be the slope of the perpendicular? Negative 3. You flip it over and make it negative. So the slope of that is just going to be negative 3. Okay. So now we're going to write the equation of the perpendicular bisector using the slope of the midpoint through which it passes. Write your final equation in slope-intercept form. So this is point-slope form. I don't know if you guys know point-slope form, because if you had Mr. Lemke, he hates point-slope form. But we love, in high school, We love point slope form because all you have to do is plug in the point and plug in the slope, and especially when you take like upper level classes like calculus and stuff, it's really easy to plug things in a point slope where y equals mx plus b is a little bit messier. So I'm gonna just plug in the point, which is the midpoint. Okay, so here's my point, -1, 6, right? So -1, 6, because I want the equation of this line that's going this way, right? So I'm going to go y minus y1, which in this case is 6, equals the slope, -3 times x minus -1, which makes +1. You with me there? That's point slope form. What? So this is the slope, and the point is -1, 6. If I distribute that through and put it into slope-intercept form, just because it's kind of easier to graph, okay, I get y equals -3x. I have to distribute this -3 through, and then I have to add 6, right? So I have -3 plus 6, which gives you +3. You guys understand what I just did? Okay. So this is the equation of your line in slope-intercept form. The other thing you could do is just plug in the slope and the point in for x and y in the form y equals mx plus b. However you choose to do it is fine. Okay. So now we got to move on to the next thing. Okay. So I think I'm gonna go back and make this bigger so that we have more room to work. Okay, so now we're gonna go to find the midpoint of BC, find the slope, find the perpendicular. So I'm gonna grab these 3 things. Okay. So for the midpoint of BC, so BC had the coordinates 5, 8, and 8, 2, right? So B is 5, 8, right? And C was, 5, 8. And C was 8, 2, right? So to find the midpoint, again, I add those 2 together. Uh-oh, doesn't come out nice, does it? Okay. So we get 6.5, 5. Any questions on it, where I got that from? Added together the x's divided by 2. Added together the y's divided by 2. Right? Now I'm going to find this slope of BC. Who can tell me the slope of BC? Is it -2? No. Because it's, if I call this y2, right? It's 2 minus 8 divided by 8 minus 5, right? Isn't that right? That's right. Which is -4, now -6 over 3, which is -2. Oh, is that what you said? Yeah. Oh, sorry. It's -2. What's the slope of the perpendicular? If that's a slope, +1/2. Okay? I'm going to do this, so I'm going to do this a little bit differently than right here, just to show you another method. If I just want to use y equals mx plus b, and I want to find the equation of the line, I just plug in this midpoint, 6.5, 5, in for x and y, and plug in this for the slope and solve for b. So in this case, I'm going to use this. I'm going to plug in this point, 6.55. So 5 would go in for y, 1/2 would go in for the slope, 6.5, which I'm going to write as a fraction, 13/2 goes in for x plus b. Everyone understand what I just did? I don't like to mix fractions with with decimals. That's why I changed this 6.5 back into a fraction. And I'm going to solve this equation for b. And I know some of you guys don't like fractions, but sometimes you got to deal with them. Okay? When I multiply fractions, this becomes 13 over 4 plus b. Right? Because when I multiply fractions, I multiply the top, I multiply the bottom. So I have 13 over 4. Yeah? Then I have to subtract 13/4 from both sides to get b by itself. Minus 13 over 4. 5, how many fourths is 5? 20 over 4, right? So I'm going to subtract 13 over 4 from 20 over 4, and I get, how many is over 4? 7 over 4, okay? Equals 7 over 4. So that's what I have now for b, okay? b equals 7 over 4, because this goes away. I subtracted this from this, and I get 7 over 4. So b is 7/4. So now I'm going to rewrite my equation in y equals mx plus b form as y equals the slope, which is 1/2 x plus 7 over 4. Yeah? Okay, with me? Some people, you're looking kind of lost there, Abby. No? You're good? Okay. So this is the equation of the line, the perpendicular of, or the median of the other thing. So, of the other side. So what I have found, I'm going to go back here to my picture, okay? So if I were to graph the one line, which looks kind of like this, right? And graph the other line through its midpoint, I'm looking for this point right there, the point of intersection, right? Okay, so I have two equations. Y equals 3x plus 3. I'm going to get a new sheet. Y equals 3x, what was it? Sorry, what was that first equation? Y equals negative 3x? Y equals negative 3x plus 3? Plus 3. And the other equation is y equals, what was it, 1/2 x? 1/2 x plus 7/4. To find a point of intersection, do you guys remember solving systems of equations from your algebra class? Okay. Who can tell me how I solved that system? Any ideas? Go ahead there, Ben.
Set them equal to each other.
Nice. Because y equals this, y equals that, you set them equal to each other. So you get negative 3x plus 3 equals 1/2 x plus 7 over 4. Okay? Now I got to get everything that has an x on one side and everything that doesn't have an x on the other side. So I think what I'd like to do is add 3x to both sides, because I don't like subtracting and getting negative numbers. So I'm going to add 3x to both sides. We'll do this in 2 steps. So I get 3 equals 1/2 and 3/2. I'm going to call that 7/2 x plus 7/4, right? Because 3 is 6/2, right? 3 is 6/2. So I'm keeping it as fractions because fractions are more exact than decimals in a lot of cases. Now what? Subtract 7/4 from both sides, right? How many fourths is 3? 12/4. Okay, so I'm going to subtract, okay? I'm going to subtract 7/4 from 12/4, okay? And I'm sorry it doesn't come out nice and neat, but that's a problem with, finding points of intersection. Sometimes they don't actually come out nice and neat. This is 5/4 equals, this goes away, 7/2 x. How do I get x by itself? Divide by 7/2, which is the same as multiplying by the reciprocal. So I'm going to multiply both sides by 2/7, okay? I'm going to cross this out, cross that out, cross that out, cross that out, and I get 10 over 28 is equal to x. Oh my God. What does that reduce to? 5/14. So let me double check to make sure I did all that right. I did. I did do it right. Okay? So x is 5/14. Let's find y. Okay? So to find y, you can plug into either of these two equations. Okay? Probably the easier one is this one because it doesn't have fractions in it. Okay? So to find the y coordinate of the point intersection, I'm going to plug in 5/14 in to the equation y equals negative 3x plus 3. So I'm going to plug in 5/14 in there. So I get negative 3 times 5 over 14 plus 3. And that gives me 15 over 14, right? Oh, that's negative 15 over 14. Negative 15 over 14 plus, how many 14ths is 3? Ugly. Multiply 3 times 14. 42 14ths, okay? Which is exactly equal to 27 14ths, is that right? 27 14ths. Does anything go in there? That's it, right? That's it. That's as far as that one goes. So your point of intersection is 5/14, comma 27/14. With me so far? I know I'm going kind of fast. So now I am going to plot that point on my graph and see if it is actually the circumcenter. Okay? So 5/14, it's really close. Well, it's a little less than 1/2, right? And 27/14, that's pretty close to what number? 2. Okay? And this is somewhere less than 1/2, right? This is less than 1/2, right? Because 5/10 would be 1/2. So I'm going to try to approximate where that center is. So I'm going to go back to here. I'm going to plot the point 5/14 2, which is, I'm going to guess, 5/14. Let's see, this is 1/2, and I'm going to go up to here to 2. And I'm going to put a point there. And if this is the circumcenter, if I take my compass, right, and put a point right here, what should this circle go through? The circumcenter is equidistant from the vertices. So if I were to make a circle starting here, oh my God, look at that. It's short, it's almost perfect. Okay? So that's, so that was my center, and notice that if I stretch it a teeny bit, I'm a little off because I'm approximating some things, but that's where the circumcenter is. Okay? So, it's a complicated process. There's a lot of algebra, and there's a lot of fractions and stuff like that, right? So what I'd like you to try to do is do the second side and see if you can locate the circumcenter algebraically, just like I just did with that. Okay? Good? It's good. It's really good practice combining your algebra with your geometry and all that kind of stuff. All right. So I'm gonna stop here. Stop my recording. And help you if you get stuck.